Welcome to Kenton's videos. Enjoy the video.
You start by confirming the hardware and drivers so nothing blocks Tensorflow. Run NVIDIA SMI and note the driver. Then install the CUDA toolkit and cuDNN matching the Tensorflow binary, because version mismatches cause failures. Create a clean conda or virtual environment, activate it, and install the Tensorflow GPU-enabled package via pip or conda. Once done, verify the install by importing Tensorflow and listing physical devices. This gives immediate feedback and makes sure you can continue with confidence. You now configure Tensorflow to use the GPU reliably. Make sure the pip-installed Tensorflow version matches your CUDA and cuDNN. Next, export or set path and LD library path so the runtime finds the CUDA libraries. On Windows, set path, and on Linux, use export. Encode enable GPU memory growth with TF. Config experimental. Set memory growth and optionally set TF. Debugging. Set log device placement true so you see where ops run. Finally, run a small matrix multiply or model fit to confirm execution on the GPU. You're ready to run full training. Launch your script and monitor utilization with NVIDIA SMI so you know the GPU is busy. Make sure TF. Config. List physical devices. GPU shows the device and watch memory use to avoid OOM errors. If needed, constrain per process memory. Once training completes, save checkpoints and validate results on the GPU. Troubleshooting tip. If Tensorflow refuses to see the GPU, check driver, CUDA and cuDNN version alignment, and reinstall the matching packages. Logs will usually indicate the mismatch.
Thanks for watching. Consider subscribing if we helped you.